Good day, everyone. It's Iluchin so I'm here today with good news for Rust developers. So, if you're a Rust developer or you're interested in building a Rust, or you're just picking up Rust and you're still trying to get a hand around building with Rust, today I'm excited to announce that I'll be starting a new tutorial series on building the dApp on Cartesi using Rust. So I know you might not be a Rust developer, but those are watching these videos and I'm not a Rust developer you see how you covered basically. So we have other tutorial series on building a dApp on Cartesi using Go, using JavaScript, and also using Python. So if you're interested in any of these languages, you could go check out those other videos. I'll do my best to keep a link to those videos in the description. But just hang on, who knows? You might just end up loving Rust and do it. So yep, this series is going to be focused on building a dApp on Cartesi using Rust. But we'll start with more of like an introduction into what Cartesi is, why Cartesi, and we'll touch about a little bit of concepts or like things you should know basically before diving into building on Cartesi, so that when we start coding along, you won't find these words too abstract or too vague to understand. So this first video is going to be more of like an introductory aspect. We are going to just talk about what Cartesi is, what you should keep in mind when building on Cartesi, and just basic concept that throughout the series I'll be mentioning too. You use this video to get a very good understanding of this concept so that in subsequent videos you'll be able to understand and pick up these things more easily. So I'd like to start by giving you a glimpse of what you can build on Cartesi. So we are going to be looking at the dApp, a game actually, that was built on Cartesi, and it wasn't really built with Rust, it was built with Python, but it gives a very good high-level understanding the possibilities that you could build using Cartesi. So stay tuned and let's go, Jay. Welcome to Owari. So Owari basically is a very interesting board game. The beautiful thing about Owari is its integration with AI. So yeah, so when you play the Owari game, basically, you have the opportunity to choose to play against an AI or AI models, basically. So they've been able to train a couple of models, I think over 10 models, that each with different strengths. So you could choose to battle any of those models on Owari. And you can also choose to create a tournament that's going to be between human beings, bots, altogether as a combined tournament. And at the end of each tournament, you can make an NFT as a reward, showing that okay, you're able to actually achieve this during this tournament. So it's very, very interesting. And I'd just like to show you guys as a possibility of what you could build. So imagine being able to build a game that integrates an AI model and everything is on chain completely. Every execution is deterministic and you can get a proof for every execution that was carried out by the model. So let's just go through a quick gameplay so you get to understand how it actually works, what it is basically. So we'll be moving to the challenge, but just quick in terms of already created the challenge. This is me against an open AI model capture. So I'll just start the game and basically it's a blockchain application, so of course it's asking me to sign this transaction. So you sign the transaction to start the game and the game does it. So we go to arena and we have our model. So no, that was a mistake. So I would like to start with this. And yep, I won. So the rule of the game basically is the first character to get over 24 stones is the winner. So I was able to get 26. So as you can see here, winner here is my name basically. So if you go back to challenges, then you can see it's all recorded here that I'm the winner basically. So the way it works is every time you send an interaction to the game, it goes to the blockchain, and from the blockchain it gets to this dApp on Cartesi. And once it gets to the dApp on Cartesi, you make execution, the AI model makes its own execution, then the result is sent back to the front end. So once you sign the transaction, it goes in. At the same time, the AI model is making its own executions and sent it back to you. So everything is happening in one simultaneous click as you're clicking. So This app was built through Python. The AI models were built and trained down using Python. So it's basically not just stopping you from thinking of that new idea, bringing that new innovation into this job, whether it includes AI or it doesn't, or it's a game, DeFi solution, or even an IoT solution. You can bring all this, build all this using Rust, using Python, Go, or any other language that contains on Cartesi. So that is what this series is about. It's about enlightening Rust developers about the possibilities of how to build that on Cartesi using Rust. So the next section we'll be moving into uh, a brief intro of the architecture of Cartesi basically. So that's what we'll be handling this video with. Then in the next video, I'll be looking at now we'll get hands dirty on building a little bit on Cartesi. So I hope this beautiful gameplay has been able to convince you kind of that it's really interesting building on Cartesi. So let's see you in the next section. So welcome to the last section of this tutorial. So for this section, we just be giving a brief overview of what Cartesi is and the architecture of Cartesi, how transactions, the basic life cycle of transactions, the way it goes through all the way from a user down to the dApp of Cartesi, and how users interact with Cartesi basically. So that's what this section will be about. So for this section, I'll be using a drawing board here, sorry, drawing board. So in my I'm looking down most of the video, so just so you know, you can just focus on the screen and understand what I'm saying basically. So we understand what rollups are basically and the solution they bring. So rollup basically are infrastructures that bundle transactions, take transaction out of the base layer, execute those transactions on chain, then return the finality of those transactions back to the blockchain, to the base layer basically, after a certain period of time. So there are two basic type of rollups, the optimistic and zero-knowledge rollup. Courtesy is more of an optimistic rollup. So it's not just an optimistic rollup, it's also an aspecific rollup. Aspecific rollup in the sense that every tap on Courtesy has its own architecture, its own rollup infrastructure suited majorly for that particular tap. Other, they share a combined on-chain infrastructure. So talking about the input post contracts, the portals, and the rest. Those are shared between different apps. But once these transactions, user transactions basically, go through the base layer, get to this input box, they are now targeted at individual role of architecture, individual role of infrastructure. So you have a role of a VM majorly to your tap on Courtesy. The advantage of this basically is that heightened traffic or high demand on one tap doesn't affect another tap basically. So the role of infrastructure you set up is left is just for you. So the strength, the speed of the VM, the resources your VM has is majorly just for your tap. So this like is one of the major advantages of utilizing an app specific role. So how do these different components basically come together? So I'm using this. So let's see. This is the EVM, and this is Bob. So this basically is the EVM. So Bob sends a transaction to EVM, for example, base optimism or even Ethereum itself. So once he sends his transaction to this base layer, he pays a fee, a gas fee basically. So this gas fee is going to be cheaper in the sense that you have to pay that through, but that app is not responsible for carrying out the entire executions for what you want to do. So you interact with the app, you send a bytecode or data chunk that you want to execute basically. So the input bus contract is targeting distance. So the input bus contract is a contract on the base layer. Collects your execution. You tell it, okay, I want to interact with this dApp on Cartesi. This is the execution I want to carry out. And the input bus contract receives that, but it doesn't execute anything. All it does basically is to receive your transaction, then emit an event. Okay, this user wants to interact with this dApp. This is the address of the dApp he wants to interact with, and this is the data he wants to execute. That's what it does. So basically, at this point, your gas fee is way cheaper because the EVM is not carrying out so much execution. So you don't have to pay for every opcode EVM executes. These are now limited sets of like executions you carry out. You send the data chunk to the blockchain, you pay the fees for that because there's a fee for every byte of data you send to the blockchain. You pay that fee, you pay the priority fee, or other fees that you might want to pay in order to get your transaction prioritized on during block construction. So you pay just this minor fees, but you do not pay fee for execution. So you pay this fee and the data gets added to the block, gets sent to the APL, and your transaction hits the input contract. The input contract emits an event that, okay, you want to interact with the dApp on Cartesi. So what happened next is at this point the input bus contract emits an event, and this event is picked up by a dApp on Cartesi. So this event is picked up by a Cartesi node, basically. So this is the roll-up infrastructure for your dApps. So we have a dApp here inside, but this is the roll-up infrastructure itself, the node. So the node listens to events from the input bus contract. At this point, since Cartesi is a specific node, we have multiple nodes deployed. At this point is a particular node for a dApp. But in future, we are looking to deploy concepts like reader node, and you could get to have other people deploy and run a node for your dApp without you doing it yourself. But for now, architecture is more of like you deploy a node for your own application itself. So we have multiple applications all listening to the input bus, waiting for an event to be emitted and matching it, okay, the address that was emitted along with that event tallies with the address of this dApp that the node is hosting. So if yes, so Bob specifies that he wants to interact with node O1, and let's say this node is node O1. So this is an object. I want to interact with node O1. I want to send the information. Hello. So node O1, the EVM, the purpose contract emitting notice. We have a message for node O1. The data chunk is hello. Node O1, listening to the input bus contract, picks up the event. Okay, fine. This person wants to interact with us. So you collect that data, and at this point, your dApp basically executes that data. So we have the front end here. So theoretically, the user is going to be interacting with the front end, and the front end will interact with the EVM using libraries and all. So once the execution happens on the dApp on Cartesi, there's a state change basically. So the dApp now has been able to execute that transaction, probably store that, okay, Bob sent hello to the dApp. And if the dApp on chain needs to send a reply, basically, there are two ways to go about it. So there are concepts known as notice, voucher, and reports. So these are basically three different methods by which your dApp on Cartesi can interact with user. Basically, can send information, can let the user know about certain executions going on with the dApp. So for the first notice, so notice basically is a provable type of execution, or like put it as a message from your dApp. This is provable, so it will be generated for notice. And this notice basically are more of like just sending out information, provable information that from executions that happen in the dApp. So Bob sends a hello world message to the dApp. We could emit a notice that, okay, we now have two messages, one from Bob and the other from the owner, because the owner basically, for example, wanted to test out the dApp before the alignment or now giving it out to other people to try. So the owner sent a message to test, then Bob also sent. So we have two messages, one from Bob and the other from the owner. So the dApp emits a notice with this information. This information gets verified, the proof is generated from this information, and at any point in time, you can prove that, okay, at some point in time, this dApp had two data sets, one from Bob and one from the owner. So that's a notice for you. It's more off-chain, just within the dApp and the user. And the next is voucher. So voucher are also information sets, but they are more of like commands basically. So the aim of voucher is to carry out executions on an EVM. So for example, we decided, okay, the first user to assign the owner to send the message to the dApp is going to get an ERC20 token or an NFT basically as a reward for interacting with the dApp. So what the dApp could do at this point is the dApp could emit a voucher that is going to be sent to the EVM, running a contract on the EVM to mint an NFT to Bob here, and that NFT is going to be minted to Bob on the EVM. It's also provable. So we have two types of provable information on command basically. One is a notice, the second is a voucher. The voucher is meant to send commands to the base layer, while the notice is just to send out information that the front end can pick up and display to the users. Then the last is we can also emit a report. So report basically are not provable. They are just meant to send status information of the current state of the dApp. For example, we just want to tell people that, okay, or someone wants to view the message Bob sent. So we've told users we have a notice that okay, we have two executions on this tab, two messages on this tab, one from Bob and one from the owner. And a user basically, another user, Alice for example, wants to know the message that Bob sent. So if Alice should send a request to know, okay, I want to know the information Bob sent, we could just simply emit a report. Okay, here you go, this is the message Bob sent. There's no proof that you asked for this information. It's just a simple request. Just like you trying to get your balance on the blockchain. You are not paying any gas fee. It's not registered. It's just a simple you get balance, you get your balance. It's like a read request. Nobody's asking you to sign a transaction to verify that you actually did that. You are just asking for data. We are returning this data to you. So that's how reports work basically. So the front end basically at this point listens to the dApp. So there are two ways for the front end to interact with the dApp on Cartesi. Um, One of them is by sending an inspect request. Then the other is to query the GraphQL server. So basically, notice, vouchers, reports, all this information go to a different component that's also maintained by the node. And this is a GraphQL server. So the data emits a notice, it sends that to GraphQL server. It emits a voucher, it goes to the EVM, but information regarding this is also sent to GraphQL server. It emits a report, information regarding this is also going to a GraphQL server. So at this point, your front end app has two ways to get information. One, you could send an inspect request directly to the app running in the node, and the report is returned to it with the state of the machine at that point. Or you could choose to not just bother the node, just go straight to the GraphQL server, interact with it, make a request, and get every information you need. So when it comes to reading data from the dApp using the front end, you have two ways basically: inspect requests or you query a GraphQL server. So when it comes to as a developer, when you're building out your dApp on Cartesi, it's important that you create certain functionalities to handle inspect requests. So a user can only query inform or use query a structure you've set out. It's just like on the base layer now we are writing a contract using Solidity. There are read functions and there are also write functions. The user can only read data in your read function because you wrote out those functions for the user to be able to fetch information and get data from, get messages or information from basically. It's the same way for inspect state too. So it's an API that's available, interacts directly with the node, but the developer needs to write out the functionalities that can be called or the data that can be gotten from that inspect state basically. So that is that for the inspect state. Then in terms of querying the GraphQL server, only information that the developer sent or structured to be sent to the GraphQL server is available for users to read. So as a developer on Cartesi, it's important that you have this mental picture of the structure of Cartesi and how data and information basically move around in Cartesi. So you want the user to be able to make a call to the machine and ask for the results for the message Bob sent. There should be a function in the inspect state under the inspect state route that'll be able to tell, okay, receive an address. For example, would you want to check his message? You say Bob, okay, it collects Bob. It looks through an array of messages, find the message from Bob, then send a report back to you that okay, this is the message Bob sent. Or I want to get all the messages. These are two different functions. One to get a single user, and the second to get all the messages basically on the dApp. So these two different functions need to be well written out by the developer before users can basically interact with the dApp through the inspect request to get this information. Then in terms of the GraphQL server, you basically emit a notice. So any notice you emit, any data you emit contained in the notice on the voucher or in the report are contained in your GraphQL server. So you basically emit a notice, send it out, that notice gets to the GraphQL server, and users can query the GraphQL server to get all the notices you've sent out and filter out the particular notice that they are interested in. So that's basically an overhead view of the architecture of Cartesi. So points I want you to notice, or I want you to take serious note of from this video is I want you to understand what a notice is, understand what a voucher is, understand what reports are, understand that the different ways to query data from Cartesi, which is the inspect request and also querying the GraphQL server. And I want you to also understand what the GraphQL server is, what the roll-up infrastructure the node is basically, and how the front end connects to these two different components. So that's the chief getaway for today's interaction. And in the next video, we'll be going straight up to building a very simple dApp on Cartesi. So this dApp is just going to be focused on sending a little bit information to the blockchain. Then the Cartesi node is going to pick this up, run certain executions, and emit a notice. So that's just going to be what the next is about. So I know this video might have been confusing to an extent for some, especially if you're just hearing about this concept for the first time. But I'll advise that you go through the Cartesi documentation one more time. And also stay tuned for the next video. The next video is going to give more clarity. So I just want to mention these concepts so that they don't sound confusing when I talk about them in the next video. So thank you very much for listening. Thank you very much for your time and see you in the next video. Stay rusty, guys.